Here we are again. This is going to be one nice long video with lots of different examples for us to look at. Before we start those examples, I just want to remind you of the 5 steps that you should actually be thinking of every time you do one of these problems. You want to start by kind of figuring out what your inner function is. Then you want to find what dx is, substitute those into the integral, then you integrate. There's only one step where you integrate, and then after you integrate, you're going to put your answer in terms of x. Now let's remember where our inner functions often are. They're often underneath the power, kind of like here, right? So I had an inner function here. It stayed underneath the power. They're above an e, or they're at the bottom of a fraction for an ln. All right, and so see the other video if you want a bigger explanation on this. But so now we're just going to be going through a bunch of different examples. So this first one, we have a couple functions here, right? We can't use our formula for this. We have a 30x, we have a 3x squared plus 1. Find the inner function. And this is one where we see, hey, well, there's an e, so I suspect that u is going to be equal to 3x squared plus 1. Now finding dx, I'm going to first note that du over dx is equal to 6x. Then I will solve for dx and note that dx is equal to 6x over du over 6x, sorry. And from here we're going to substitute in the things from 1 and 2, this and this, into my original integral. So notice I have a u right here, and I'm also going to substitute that. So I'll end up with the integral of 30x e to the u, and then we'll have du over 6x. Now, some of you might stop and say, well, I have a problem, I still have x's, but you have to simplify. All right, so this is all multiplication. So we can shuffle this around, right? So we'll have 30x divided by 6x, e to the u, du. And this is where my x's will cancel out. And from here, I'm going to get 30 divided by 6, which is actually 5, and I can pull that 5 out of the integral by the properties I learned in that first video we did. Sorry, 7.1, I mean. So then we'll have e to the u du. And from here, this is just where we use the rule. Well, that is actually step 4. So now we'll integrate. So we'll have 5 e to the u plus c. And then we substitute back in our original function, which was 3x squared plus 1. So we'll have 5 times e to the 3x squared plus 1 plus c. And you should be able to check that to verify that you got the right thing. Taking the derivative of this will indeed get you this. Now let's take a look at our next example here. We have 30x plus 15 divided by x squared plus x. And let's think about where our inner function is here. It's either going to be underneath the power, above an e, or at the bottom. Here we really only have one choice, is this x squared plus x. So if I make u equal to x squared plus x, and then find dx, so du over dx is equal to 2x plus 1. So dx is going to be equal to du divided by 2x plus 1. And now we're going to substitute. And so substituting this one's going to be a little bit messy. I have my u here and my dx there. So I'll have 30x plus 15 divided by u, and then I'll have the du over 2x plus 1 there. And you might say, oh, we're in huge trouble again. We got x's everywhere. But let's take a look at what we really have here. 30x plus 15 divided by 2x plus 1 times du over u. So does this simplify at all? And it might take you a little while to see it, but it actually does. If we pull a 15 out, we can pull it all the way out of the integral here. So we'll have 15 integral. We're pulling a 15 out of that top part. So I'm going to write 15 2x plus 1 divided by 2x plus 1 du over u. And this is something that will happen sometimes. It's something you have to get comfortable with doing, kind of factoring out just a constant so that you're able to simplify. So we'll end up with 15, the integral of du over u. So our simplification is done. We have to come and integrate now, and so we'll get 15 ln of the absolute value of u plus c. And now we have to get our x's back, and so for that we come back to 1. So u is x squared plus x, so my final answer will be 15 ln of x squared plus x plus c. Okay, so we're just following these same 5 steps for everything. Mechanically, it's pretty much the same thing. Well, let's keep going here. So I believe this is one of the ones on your part 1 assignment. Let's take a look at what we got here. So we have to find our inner function. So you might think, well, what about the bottom here, right? So we either have underneath the power, the bottom, or above an e. You might say, well, let's try u is equal to the square root of x cubed plus 2, and then I would have du over dx is equal to 1/2 x cubed plus 2, the negative 1/2 times 3x squared. This is getting really bad, right? It's going to turn out, if you do this, you're going to still have x's left over. And so you're welcome to try it. It's not bad to try it. But so since this didn't work, what's the other thing that might work here? And so it turns out that we really want to think about this is 9x divided by x cubed plus 2 to the 1/2 dx, or even better yet, think of it as the integral of 9x x cubed plus 2 to the negative 1/2 dx. And from there we can see, oh, you know what? This x cubed plus 2, that's really underneath a power. So this is type A, right? And we'll go with u is equal to x cubed plus 2, so that du over dx is equal to 3x squared, or that dx is equal to du over 3x squared. And from here, sorry, and this should be a squared. I'm going to add that in a little bit late, but otherwise the example won't work. So now when I substitute this in, notice I have my u here, I have my dx here, so I'll have the integral of 9x squared u to the negative 1/2, and then du over 3x squared. Now again, this is all in multiplication, so I can shuffle it around. 9x squared divided by 3x squared, u to the negative 1/2 du. My x squareds will go away, and I'll end up with 3 integral u to the negative 1/2 du. Now, if I actually do my integral here, I will end up with 3 u to the 1/2 divided by 1/2 plus c, which would be equal to, and multiply by 2 over 1. Get a 1 on the bottom, and I'll have 6 u to the 1/2 plus c. So if I change it back to my x's, I look at what my u originally was. U was equal to x cubed plus 2. So my final answer would be 6 times x cubed plus 2 to the 1/2 plus c. Okay, we're getting near the end here. There's a couple more tricky ones that are in your web work though, so I'm going to keep covering those, but you can feel free to try as many as you need to at this point. One of the tricky ones is this thing. This looks a little bit bad, right? We have an ln, we have a 2x. You might think, well, what if I made u equal to 2x? And that's not going to work. You can try it out, but you will not be able to get rid of this x here. So what are we left with? And maybe I can help you out a little bit here. If I put parentheses around this ln, and note that I have this thing squared, this is actually really a type A. We have our ln, and it's underneath a power, and so we'll have u is equal to the ln of x. So then du over dx is going to be equal to 1 over x. That's the derivative of ln x. And so finally, we'll solve for dx. We'll get dx is equal to, now be a little bit careful with how you do this. So it would be du divided by 1 divided by x, which you can really just write as x du. All right, I just multiply each side by x. I multiply each side by dx, multiply each side by x. This is what I get. And then I'm going to substitute and simplify. So I have my u right here. I have my dx right there. So I'll have the integral of u squared over 2x times x du. And oh, look at that. X's go away. And I can really write this as 1/2 integral of u squared du. Looking good, right? So now I'm going to be able to integrate, so I'll have 1/2 times u cubed over 3 du, which is 1/6 u cubed sorry, not du, plus c. A little bit tired today, I think. I'm making a lot of mistakes. So I have a plus c there, and I'm going to change my u's to x's. Come back up here and check what my u was. It was the ln of x. So my final answer will be 1/6 ln x cubed plus c. And I really encourage you here to actually just try checking some of your work, right? If I take the derivative of this, I should get this thing here. And you will do that if you do it. It's good practice, though. So go ahead and give it a try. Believe we have a couple more tricky ones. Yeah, here's a tricky one. So we could go with maybe u as our bottom function. Maybe it's above the e. And you can try whatever you like. The best choice here is going to be that thing on top of the e, right? So u is equal to, it actually ends up being both of them, but we'll see why in a second. It's better to think of it as that. All right, so our inner function is u is equal to the square root of x, so that du over dx will be 1/2 x to the negative 1/2. And then, because this is really u is equal to x to the 1/2, right? So dx is going to be equal to, now this is, you just got to be able to practice your algebra here. So I'm going to multiply each side by dx, and I'll also multiply each side by 2 root x. This is, well, so let's think of it like this. So this is really 1 divided by 2 root x, right? So now dx is going to be equal to 2 root x du. All right, so we're going to multiply each side by dx and 2 root x, and that's what you'll get, right? And so now if we make our simplifications, we'll have the integral of 9e to the u. I'm going to leave that one on the bottom as root x, and we'll see why in a second. All right, so now my dx is going to turn into 2 root x du. And look at what just happened. I have a root x on the bottom, a root x on the top. Those are going to cancel out, and this whole thing will simplify to 18 integral of e to the u du. So I can come back here and integrate it. So integrating e's is really easy. It's going to be 18 e to the u plus c, and then I'll convert my u's back to x's. Now remember, u was the square root of x, so 18 e to the root x plus c. Okay, so I think we're just about there with the substitution problems. I have one more kind of trick problem for you. I imagine a lot of you will be watching this part of the video or skipping along to it when I direct you there, when you don't know how to do this one in your web work. So you will see something like this, and it's like, I know what u is, right? There's only one thing it can be here. It is underneath a power, right? So, well, I'll take u is equal to 3x squared plus 2. I don't even know why I'm writing this, because all of you have tried this at this point. So du over dx would be equal to 6x, so that dx is equal to du divided by 6x. And then when you try to simplify, you're going to have the integral of u squared, and then you'll have du divided by 6x. Where does that x go, right? What is the problem here? There was only one thing to do, and I have a problem. So how does this one actually work? It is not a substitution problem, right? So when you cannot get rid of the x's, one of two things has happened. You did your substitution wrong, you need to substitute something differently, or the other choice is that it's not a substitution problem at all. And that's exactly what this one is. So the way you have to do this one, this is not substitution. You actually just have to FOIL this out. All right, so we'll take the integral of 3x squared plus 2, and we'll have 3x squared plus 2 dx, and then we do FOIL, first outers, inners, last. So this is the integral of 9x to the 4th plus 6x squared plus 6x squared plus 4 dx. Simplify a little bit more, integral of 9x to the 4th plus 12x squared plus 4 dx, and my final answer there will then be 9x to the 5th divided by 5 plus 12x to the 4th, x to the 12x cubed divided by 3, which is going to be 4x cubed, and then I'll have plus 4x plus c. Okay, so it's just a polynomial, no substitution, just a little mean trick there we pulled on you at the end. But the takeaway you should be getting from this is that if you have x's, you either got to look for a different thing to substitute, or it's not substitution at all, right? That x is a problem, and this is how you have to deal with this particular problem, but it's a good sign for you to keep track of.